Now, folks, tonight we've got Matthieu Napoli joining us from France, and he's connected to us here, so hopefully all going well. In just a moment, he'll be sharing his face with us. Excellent, good to see you, sir. Yeah. Everybody say hello.
Hey.
Good. Now, just to check again, can everybody hear Matthieu okay? Over the speaker at the back? Beautiful, yeah. Sounding good. So I've been pretty excited about Matthieu coming to talk with us about the project, which he's going to tell us a little bit more about, because I've been working with serverless architecture for a little while now. I've been really enjoying it. And of course, was wondering at some point in time when somebody would get toward deploying something onto Lambda with PHP. And we're going to hear much more in just a moment. So, well, Matthieu, thanks again. I'll hand it over to you and we'll go from there. Cheers.
Okay, perfect. Okay, perfect. so let's get started. So this is a talk, as Dave said, about serverless, about how to run PHP on serverless providers, and most specifically Amazon Lambda. And the way I usually talk about serverless and Amazon Lambda is I start from today, I start from the end, and I try to explain what's possible and everything I've learned from what I've done with it. And this time it will be a bit different. I will start from the beginning. I will start from when I discovered Amazon Lambda and all the misconceptions I had. And I will try to go along that way to try to share all that experience and the way I understood Lambda over time. So hopefully it will be a bit different and interesting. And the journey towards serverless starts with JavaScript, not PHP. And it starts with a website called Return True to Win. So absolutely no relation at all with serverless. At the time, it was maybe 2 years ago. And I just discovered this website. It was a little game for JavaScript developers where you basically have a piece of code. Here it's a function and you have to make it return true. So nothing to do with serverless, just a little JavaScript game. And the thing is that it plays on very weird stuff about JavaScript, so you have to try to find a solution to make the function return true. So here you have to find something that is not equal to itself. And I will spoil the answer, but one answer could be not a number. Because in JavaScript, not a number is a special constant or construct. I don't really know what it is, but it's not equal to itself. So a pretty fun game. And obviously, I thought, well, we could do this in PHP because PHP has so many weird stuff that would be pretty fun, and it would be a great way to learn about PHP specific stuff. So I wanted to build that in PHP. In the end, that's what I did. So again, 2 years ago, working on that on my computer. As you can see, this is very, very much the same thing. The website was so perfect, so there I wanted to do the same thing. So return to win in PHP, you have a piece of code, and you have to submit the form to try to fill in the blanks to make the function return true. If you make it return true, you win and you move to the next level. So here I'm playing on, I will spoil the answer. You have to find something that is greater or equal than 1, lower or equal than 1, and not 1. And one answer could be 1 dot, the float number, because it's not strictly equal to 1, the integer. Yeah, playing on all those weird PHP stuff, you can do a lot of what I'll call levels. So it was pretty fun to build and pretty fun to play with. And then came the time to put that website online. So I'll get into it. I just want to explain how things work in that website. I have basically 2 parts. I have the proper website, which receives the GET request and the POST request from the internet. So it shows the form, and when you submit the form, there's a POST request that is sent to the website. And then the code, the PHP code that we need to run, it needs to run on the server. It's not like in JavaScript where you can run the code in the browser. So I have a little, like a sub-application, which is called the evaluator, which is responsible for running the PHP code that was submitted. And I wanted to separate the website and the evaluator because if anything crashes in the code that was submitted, then the website will still run fine. And now we have the problem of running the PHP code in the evaluator, or what I call eval as a service. So the evaluator does something like this. Basically, you take something coming from the internet, some code, and you try to run it. And that's really bad. That's something you should never do. That's called an eval injection. So I was left with some code coming from the internet and wanting to run it somewhere securely. Because I didn't want to expose my server to the internet. So you may be thinking about it. That's what I tried to explore at the time. I tried to look into virtual machines and obviously containers. And those are two great ways to try to isolate things. Virtual machines are really good at isolating things. Obviously, they are very secure, but this is really a pain to set up and really a pain to manage. And I'm a bit lazy, and this was way too much work for me, and I don't know how many servers I would have needed. So yeah, too much. Containers, they are much more lightweight, but setting them up so that they are secure and so they are managed and having multiple instances of the containers, this is a bit of work as well. And yeah, making it secure is definitely a bit more work, and I don't feel good enough to do that. So containers, a bit of work. I had this friend who was like, yeah, containers a bit of work, but just use Kubernetes, man. Just use Kubernetes. And I don't know if you've tried Kubernetes, that it's a really great thing, but it's just way too complicated. So I think I said something like, bugger off, mate, or something like this. But anyway, no Kubernetes, no Docker, no virtual machines. That's when I discovered Amazon Lambda. So Amazon Lambda, I will explain to you and through the slides how I understood Amazon Lambda at the time. This is a very short-sighted way of understanding the product. So Amazon Lambda is basically a way to put some code online. So this is an example of JavaScript code, because this is the example that you will see often. When you put code on Amazon Lambda, you basically write it in a function like this. The top parts here, I don't know if you can see my screen, my mouse, but you have a function that takes an event. You can also take a context, but we don't really care about the context. You take an event and you return a response. So you can do whatever you want inside of it. And below, I show an example on how to invoke Lambda. So this is using the AWS CLI tool. You can use anything that's an API or whatever. But what's important here is that you can invoke the function and pass some payload, some event data as JSON. And then the code runs in the cloud. This is basically it. You don't really know how the code will run. It runs in the cloud on a server. You don't know about the server. You don't know about the containers. What you do know is that it will run in a container. It will run on an isolated container from other clients, and that's it. So, if I wanted to describe that very, if I wanted to describe that very poorly, I would say this is a way to, to run the code in a container without having to deal with the container. So this is great. But yeah, this is a JavaScript example. What about PHP? And you see, 2 years ago, there was no support for PHP on Amazon Lambda. There was no way to run PHP on Amazon Lambda. But that's okay, actually, because, I said that the JavaScript code run in some sort of container. And what is a container, after all? It's just like a Linux environment. So what I started doing, and I'm not the only one, there were several blog posts about it, but what I started doing is something like this. So this is a very rough example. This is not the actual code, but you write a JavaScript Lambda that will execute the PHP binary to run your PHP script. What you have to do, though, is that you have to compile PHP, you have to put it inside your Lambda with your JavaScript code, you have to put your PHP code with your JavaScript code, all of that inside your Lambda. So it's a zip file, you send it to Amazon, and it actually works. So here you can see that I spawn a PHP process and I pass the event as a command line argument encoded as JSON. And yeah, that's basically a JavaScript proxy that will forward the event to PHP, and then PHP sends a response, and JavaScript forwards the response back to Amazon. And as I said, it works. And it's how you could run PHP on Amazon Lambda at the time. So to sum up, this is how I understood Amazon Lambda at that point. Amazon Lambda is a good way to have your containers, your Docker containers and whatever, managed by someone else. You don't have to care about how to run them in production. This is very, very far from the truth, but still this is pretty, I think it is a good way to understand it. And thanks to that, I put the website online. So it's still online right now. It's returntrue.win. You can go and play. And it's actually running with 2 Lambdas. So there's the one for the website and there's the one for the evaluator. And yes, I built the website as well in PHP using the same technique because you can connect Lambda to basically to the internet. You can connect Lambda to HTTP servers. So whenever you have the domain name here, and whenever you have a web request to that domain, it will be forwarded to the Lambda, and in the event variable, you will receive the HTTP request. And then you can send a response, which is actually the HTTP. You can send a Lambda response, which is the HTTP response. So possible to make website, possible to make just a piece of code. Pretty interesting. And I shared the website online. So this is the first month. I shared it on Twitter, and it got shared on Reddit and other websites. So it was pretty fun. People kind of enjoyed it. And I got, yeah, a bit of traffic. Not huge traffic, obviously, but quite a bit of traffic. And what was really great to see is that no matter how many people were on the website, I didn't have to do anything. The containers and the website was all scaling automatically. And it was now Amazon's job of making sure the website was running correctly. So as a developer, this was absolutely amazing to see that. I didn't have to care about, how much CPU was used and how free memory I had left. It was just running, and that's it. So my understanding of Lambda kind of evolved, and I thought, okay, these are managed containers, but they are also auto-scaled, which is pretty cool. Anyway, first month is going really great. Nothing to do, just fixing the bugs. And the question still is, how much will I pay at the end of the month? And yeah, at the end of the month, I paid $3. Oh, sorry, I paid 4 Australian dollars for the whole month. So pretty cheap for the service, pretty cheap. So now, now that I guess I've got you a bit intrigued on how it works, let's get into it. And to explain how Amazon Lambda works, because it's really different, it's actually really different from traditional hosting. So to explain how it works, let's just look back at how web applications run today. And let's say they work like this. You have the green arrow, it's an HTTP request. So you have an HTTP request that comes in, and obviously you want some code to execute and return a response. So this is the blue bar. The blue bar is the code. But in reality, it doesn't work like that. It's more like this. You have a web server that is running all the time, like Apache or Nginx or whatever, and it listens on the port 80, and it sits there and it waits for requests. And whenever there's a request that comes in, the server catches the request and execute your piece of code you want to be executed, like your controller or your application or whatever. And this is the way things run today. And to move from traditional hosting to function as a service or to serverless or to Amazon Lambda, whatever the name it is. But to move, we have to move from that to that. That means we have to get rid of anything that waits, anything that pulls. We remove the servers, we remove the daemons, we remove the background jobs, that everything that stands there and waits, anything that pulls. And we only write code that responds to events. That's really, really important. So basically, it's now Amazon's job of running the web server and waiting for requests. And we only write the code that responds to the request. And I'm saying event, because the event can be an HTTP request, but it can be like a job in a message queue. It can be a cron. Every day at midnight, run this piece of code. And it can be, there are so many events on Amazon. But yeah, what's really important is understanding that it's based on event. And then your code runs, and that's it. It runs for a few milliseconds or even seconds, and that's it. And that's where it gets interesting, is that the way you pay for that is not, you don't pay for a server. You don't pay for a specific amount of RAM and CPU and stuff like that. You pay for execution time. So this is the price of Amazon Lambda. If you have one Lambda and you run it once, that's what you will pay. So basically, you will pay $0. And you know, with return to win, I was paying actually that amount multiplied by the number of seconds of execution of PHP and the number of invocations. So this is why it can get pretty cheap compared to traditional hosting, is that even though you may have a bit of traffic or not, but you don't pay for wasted resources. You don't pay for a big web server that sits there during the night with no traffic, or that sits there, you know, between requests, just waiting for requests. You don't pay for that. So yeah, you pay only for the actual execution time. And the way it scales, because I said that you know, I paid only $3, but also it scaled automatically. So the way it scales, it's really interesting as well. Technically, how it runs is through some kind of container. I mean, it's not really a container, but I will get back to it later. Let's pretend it's a container. So whenever there's, you push your Lambda, it's deployed, but there is no request. So when there is no request, there is no event, your code is not running. You pay for nothing and nothing is running. Whenever there's your first request, Amazon will boot a new container. Your code will be loaded inside the container, and it will run and process the event inside the container. Run and then stop, return the response, and then the container can be stopped by Amazon or frozen. It can be, you know, completely wasted because we don't really care. What's really important is that it's all stateless. One piece of code, one instance will handle exactly one request. And what I mean by that is that let's have a look at what happens if there are 1,000 HTTP requests at the exact same time. This is what happens. You will have 1,000 containers that will boot in parallel with your code inside of it 1,000 times. And each instance of your code will handle exactly one request at a time. So there is no shared state. There is no concurrency issue. There is no overloading of whatever. It's just one container, one instance of your code takes just one request. And that's what makes it so easy to scale, because you can have those containers run on separate servers and separate data centers. It doesn't matter, since it's all completely decoupled from each other. So that's a really, really clever way to run the code, even though it's not, you know, as efficient, obviously, as having one big server. So, you know, in PHP, you may be thinking, yeah, in PHP, this is pretty, it's a bit familiar, you know, but if you take Java applications, if you take Python, Go, and Node applications, this is a really huge change in architecture. And because you have to, like in those kind of languages, the application is just one process, one big process, and you have to split up all that process. So it can be a bit of a big refactoring. And yeah, to sum it up, this is how I started to understand Amazon Lambda, a bit better. Amazon Lambda is hosting managed containers for you, and it's auto-scaled on a very, very fine level, like at the request level, and it's built on usage. You are built at a very fine level. So a big change from traditional hosting. Now, it's all great and fun, but compiling PHP and writing the JavaScript file and doing all of that every time you want to deploy and put a PHP application on Lambda, it's a bit annoying. It's a bit tedious. So that's why I started the open source project called Bref. And so Bref is on GitHub. And at the time, Bref's goal was to basically add support for PHP on Amazon Lambda. So whenever this is an example of how it works. It's a composer package, and whenever you want to use it, you just require it, you run Bref init, it will create just like 2 or 3 files, and then you can deploy. And the deploy step will take care of downloading a compiled version of PHP and write a JavaScript file and connect everything together. So not the official way to run PHP, obviously, and a bit weird with a JavaScript proxy, but the thing is that it worked. So moving on, a few months later, I mean, basically at the same time, about a year and a half ago, I was working on another project called PrettyCI. And PrettyCI is a website, it's a SaaS, where you can sign up with your GitHub account and it will run PHP code sniffer and PHP CS fixer for you in the cloud. So it's a like continuous integration for the coding style in PHP. And I started completely without serverless. And the idea was you push your code to GitHub and then you have a pull request and PHP code sniffer or CS fixer will run and validate your pull request. And then the build is either green or red. And the way it worked at the time was like this. So you have your laptop, you push some code to GitHub, and then GitHub with a webhook will call PrettyCI's API. And the API of PrettyCI will, the webhook contains a commit, so it will put the commit inside a job queue. So the PrettyCI API is a Laravel application. Very classic application, it will put the job in a message queue, so it's a Laravel job queue. And then on the same server, so it was running on a VPS on DigitalOcean, on the same server, you have 4 workers that are just basically waiting for jobs to process in the message queue. So whenever there's a new job, the worker will take it, check out the project, run PHP code sniffer, collect the result, and call the GitHub API to update the status. And it was running okay. I started using it for myself and for a few open source projects, and it was running fine. But the thing is that I was worried about 2 things. The first one was the isolation between clients, because all the workers were running on the server and in the same machine, and I was checking out the code and running some code, and there was no isolation between clients. Not great. And the second thing I was worried about was the fact that I had only 4 workers. So if 8 people pushed at the same time on their GitHub accounts, I would have 8 jobs in the job queue. And then there would be a queue and a waiting queue, and people would have to wait for their pull request to be analyzed. And that's not really great. So I could try to add more servers and run the workers in a distributed way and try to scale them. But again, I'm lazy, and this is a bit of work. So as you can guess, what I started doing is migrate the workers to Amazon Lambda. So now the way it runs that whenever there's a new message in the message queue, a new job, that job will trigger Lambda automatically, and Amazon will immediately instantiate a container with the code inside of it, and everything will run completely isolated in a container. And so if I have 1,000 people pushing at the same time, then I will have 1,000 workers that will boot at the same time, and there will be no waiting queue anymore. And that's what I did, and that's how it works. That's really great. So as I said, this is what I often see on GitHub. No waiting queue. So you push your code, and then in less than 5 seconds, you have a build that is either green or red. And you can compare with, Travis or other continuous integration systems, where often you have to wait, not for the code to run, but you have to wait just for a container to be free. So great user experience. For me as a developer, it was really great experience because I don't have to worry about scaling. I don't have to worry about, isolating stuff and running the containers. It's just done for me automatically. What's great as well is that it's really cheap. I only pay for what I actually use, so it's really proportional to the usage. And that's how I've been able to offer free plan for open source projects. So really great experience overall. And if you have workers, I highly recommend you to start looking into it. So I did that on PrettyCI. I started talking about it, and I had a friend at the time who was and still is working at Enoptia. And Enoptia is a French startup, so it was a year ago, less than a year ago. And they are, what they do is they process a lot of energy bills. And so they don't have a lot of web traffic, but they have a lot of background jobs. They download PDFs and they extract data, and then they build reports and compute values and stuff. So they have a lot of background jobs. And they are a startup, as I said. So they are growing. They are handling more and more jobs every month. And at first, what they started with is that they built their application using microservices running in PHP on Amazon EC2. So EC2 are just servers. And they had to manage the servers, they had to manage the services, they had to scale them. And over time, as the traffic, as the job number grew, they had to scale the servers, which was really painful for them. And they had to pay more and more each month. So their Amazon bill was growing and growing. And as I talked about serverless and PrettyCI and all of that, they were interested. And what they started to do in July, they started to move from EC2 to Amazon Lambda using bref. So it took like a few months, and so this is not finished, but from the moment they started migrated, this is their Amazon bill. So it was increasing every month, and it started decreasing from the moment they started migrating to Amazon Lambda. And this is really great for them because, as a startup, it's always great to save money. I don't have global numbers here to share, but they allowed me to share one specific number about a microservice that was completely migrated from EC2 to Amazon Lambda. And they went from $800 per month to $90 per month. So it's a pretty good deal. They were also very happy because they have much less to manage. They didn't have to worry about scaling. Before that, they were worried about signing a big client, but from now on, they just were not worried anymore. And it's interesting technically, and even saving the money, but it's also really interesting for a business, especially a startup, to not be afraid to grow. And that's what they really gained here. So there you go. It was working. Yes, it was hacky. It was weird with the JavaScript stuff. And yes, there was a little bit of performance impact because of the JavaScript proxy and because of the containers and booting in real time. But still, it was you could work with it, and you had like 20 milliseconds or in the very bad situations maybe 500 milliseconds of delay. But it was you were able to build something on top of it and save some money or make some money or whatever. So not perfect, but working. And thankfully, that changed. In November this year, there was the Amazon reInvent conference. So Amazon, they hold a conference every year in Las Vegas. I think it's a really big thing. And I really didn't care every year about it. But this year I followed it with like a lot of excitement, because they announced a lot of stuff, like a lot of new products and features, but they announced a lot of stuff related to serverless. And Amazon Lambda was a very big part of the conference. The first interesting thing they announced is FIRECRACKER. So you know I said that Lambda runs with containers, but they aren't actually containers. At first, that's what they used, but they built something called FIRECRACKER, which is now open source, which is a technology in between virtual machines and containers. And they built that so that they can have the best of virtual machines, like the complete isolation of resources and of security related. So isolation of a virtual machine, but the low overhead of a container. And with this new technology, they've been able to increase and improve the delay and all what's called cold start and all the performance related topics. That's what they call micro VM. So we don't really care about that in the end. That's just a technical detail. We don't want to use it directly. We don't want to know about it. But I think that's just interesting to know that it's not containers, and that they have something very optimized for booting so quickly and in parallel. And the second thing, the most important thing they announced at Amazon reInvent in November was that you could finally run custom runtimes on Lambda. And by runtime, that means you can run anything you want, like PHP, but you can run Bash script as well. You can run PowerShell, Lua, Haskell, whatever you want. So this is really big news. It's interesting because they didn't add PHP support, but they added an open API to add your own support for your own use case or your own language. So at that time, I was extremely excited, but I also thought that maybe this is the end of Bref. That's okay. That's great. It was useful when for a time, but now we can just run PHP on Lambda with the custom runtimes. And yeah, you can just run PHP. You just have to start to find the current AMI that runs on Lambda. Then you have to compile PHP on that AMI. So to compile PHP, you have to configure it properly. And then you have to write a layer bootstrap. You have to package the layer with the bootstrap and PHP in the libraries. And then you have to publish the layer. And you can use then the layers ARN in AWS SAM, and then you can deploy with SAM. So that's you just have to do that, You just have to. It works, and people are starting to do this. Sorry, but yeah, that's not good enough for me. That's not good enough for me. This is way too complex. And this is what I've been doing since with a few contributors as well. We've been working on the new version of Bref, which is version 0.3, because the one before that was 0.2. And we've been working on that new version to basically simplify how to run PHP on Lambda. And that has been extremely interesting and exciting to work on that. We've been playing with pretty weird stuff, doing some benchmarks on what kind of PHP configuration would be the best to run on Lambda, and we started playing, with the multi-threading and forks, and I even, that's the first time I went into the actual source code of PHP. I tried to build my own custom ACE API and special mode for PHP for Lambda. So there's a lot to explore and experiment with, but in the end, got back to the roots of PHP, and we now are able to offer 3 runtimes for Amazon Lambda. And I will get into the details, but basically you can run PHP functions, just like the JavaScript functions on Lambda. You can run HTTP applications, so that's really interesting here, and you can run console applications. Now the PHP function runtime, the way it works is that basically you configure your Lambda to say, hey, my handler is function.php. So you just put a file, whatever the name is, but you say to Amazon Lambda, the function you need to run is in this file. And then in that file, you have to basically declare an anonymous function like this. And that's it. You can start coding in PHP and write whatever you want here. So this is the Lambda way of writing functions. And it's maybe not the most common use case we have in PHP, but still it's useful for some situations. What I think is the most useful is obviously running HTTP applications. So here, what you have to do is basically say, just like in Nginx, you say, my PHP entry point is index.php in that folder. And it can be anything, right? But you have to point Lambda to a single entry point. And then you can run here. It's an example with Slim, the Slim framework. But you can run, anything that runs in PHP. It's running with PHP FPM. So it's the same environment as with Nginx and Apache and classic stuff. So this is a Slim example, but you can run Laravel, you can run Symfony, and the goal is to support any kind of framework. Even WordPress, yes. And there's a third runtime. Maybe I'm a bit late. I'll move on quickly. So this is just to run the Symfony console and Laravel Artisan in Lambda. So this is pretty helpful to administrate the Lambda. Now, as I said, the goal is to support Symfony and Laravel, so I work a lot on documentation, and this is what I'm doing at the moment. And yeah, trying to improve that over time. Now, I'm really happy to say that I've been working for those last 2 months or something on this new version with the contributors, and my goal is to be able to release this new release today. I mean, for you it will be tomorrow, but to finish that today. So yeah, I'm excited to release that and to let people play with it. There's a new website as well with a completely rewritten documentation. It's bref.sh, and if you want to have a look at it after, it's already online. It's just not tagged yet. So to conclude and finish here, I've talked about the technical aspect of serverless, and more specifically Amazon Lambda and function as a service. And I've talked about the pricing, the billing model, and this is really interesting. But the more I use it, and that's where I am right now, the more I use it, the more I play with it, I think there is something more. It's really hard for me to explain what it is. I don't even know, but I feel like this is a bit like the cloud. At the time, it's really going to change our industry. It's impacting how we pay for software, but also how we can build it, and even in teams, the skills needed to put an application online. And with the way the pricing works and the way on how simple it could be, it's not simple enough yet, but it will be eventually. I think it's really interesting to think that you can have a team, and you can have people working on new projects, and they don't have to ask for permission for a new server. They don't have to ask for a sysadmin to manage the servers. They can just start coding and deploy the application, and it will cost zero until it's actually used, and you can experiment more quickly. You can empower people to experiment and to develop and to try things. So this is really interesting, and I guess we will know more about that in the coming years. But that's something I'm really interested in, see how it turns out. So thank you for listening. This is bref.sh. This is the website. I will be very probably tagging the release today. I've also started the newsletter called Serverless PHP News. So it's all the news related to PHP about serverless. And yeah, this is my Twitter account if you're interested. If you have any questions, we can maybe take them here. I don't know about time. I'm happy to answer them on Twitter as well. And if you want to get started, start small, really. Start really small, experiment. If you are interested about working on this further, I'm also available as a consultant. So feel free to send me an email, and thank you.
Well, first of all, just want to say a huge thank you to you, Matthieu, for joining us at this point in time, because it's early morning in France. So a big round of applause. Thanks a lot for joining us here. Very exciting topic. Really, really appreciate it. And yeah, we've definitely got time for a few quick questions. Now, just so everybody's aware here, we're actually going to have to use the microphone for the questions so that Matthieu can hear. Has anybody got a question? I'll come running to you. Who's got a question? Ben's got a question. Now, just want to bear in mind that we are recording, Ben, and there could be children present. Okay, here we go, say.
No heckling today. No, that was great, mate. Hey, so what are some of the shortcomings as far as stateless? Obviously, database would be the first one. Or not shortcomings, but how do you manage that? Obviously, like AWS has options for databases for their own system. Like, yeah, I guess the things that can't be stateless, how do you handle that?
Yeah, so this is something I didn't have time to mention much, but there are a lot of problems basically that arise with all of that. So database is one of them. You know, if you try to make the code serverless like this and everything hits the same database, which is not serverless, then obviously you have a bottleneck. And it's really bad when it starts to scale because Lambda will scale as much as it wants and the database will just be overloaded. So they started offering something called Aurora Serverless at Amazon, which is basically MySQL or PostgreSQL, which runs a bit like Lambda, like scalable at a very fine level. But it's really in beta, I think. But it's really interesting. No, it's not in beta, sorry. It's stable now. But I haven't had time to play too much with it. And they focus a lot as well on DynamoDB, which is now serverless as well in the same sense that you pay only for what you use and it scales very quickly. So they want you to use DynamoDB. I mean, it's not perfect. And if you want to just run Laravel or Symfony with, you know, Doctrine or Eloquent, I think there's a bit of work. And this is what I want to focus on in the next months to try to maybe bridge the gap. But it's not, today it's not perfect, really.
Awesome. Good question there, Ben, and thanks for the answer as well, Matthieu. I've got a quick question because I remember when I first saw Bref, when you were working on it before, that you were leveraging serverless framework underneath the hood. And now you're leveraging AWS SAM, the serverless application model. So I know that that's a bit of a change. I was just keen to understand a little bit more about why from your perspective.
Right. So there are two things here. The first one is that I decided to move entirely Bref to Amazon. And that's a choice. Maybe not the best one, we'll see over time. But at the time today, I consider Amazon Lambda to be, and the whole AWS ecosystem around to be the best solution, really. So I want to offer a solution that works, and it's an opinionated choice. Opinionated. And the second part of this is that since I don't have to support multiple cloud providers, this feature of serverless, the serverless framework, is not that interesting anymore. And SAM has really great features like running Lambda locally, running API gateway locally, all that in Docker. You can run DynamoDB as well locally. So you can have the same environment locally as online on AWS. So that's really, really interesting. That's the main thing that got me, that decided me.
Yeah, that makes a lot of sense. I was using serverless framework before with the idea that I would be trying to avoid vendor lock-in and being able to leverage the corresponding functionality on different cloud platforms. And the thing is, what you're doing just now with Bref, of course, is using those layers, right? So having that custom runtime, you're leveraging that directly. It makes perfect sense. Another thing about the serverless framework was that they moved away from semantic versioning, which perhaps made it a little bit harder to build something on top of to be able to work with it in a predictable way going forward. It was changing rapidly. Anyway, I really appreciate that answer. That was really great. It makes perfect sense. Anybody else got any questions? Okay, we've got more questions. I'll ask somebody who hasn't asked a question yet.
Hey, just a further question on like multiple processes and then regarding to stateless functions, is like database one thing, but if multiple processes, then you have to share the same resources. So have you thought about like how we're gonna, manage those processes and then introduce some sort of like control or monitor over that?
Yeah, so it's not really possible to do that. I mean, technically, I guess you could, but really the approach with function as a service and serverless is really to have stateless stuff. And sometimes that means changing your application quite a bit. So it's really fun to say, I mean, I understand as well that saying, hey, just put your PHP application out there and it's fine. It's not always as easy as that. And sometimes you have to think differently. For example, yeah, with the workers, and that's something with the Laravel job queue. You have processes running, and it can spawn sub processes, I think, but that's not the serverless way. So you have to kind of try to make everything stateless, and I mean, try not to do that. There are solutions on AWS, like you have step functions, and there are many solutions to have lambdas communicate with each other, usually with the message queue. But it really depends on the actual specific use case.
Thanks for that, Matthieu. One last point maybe to mention. You talked before about not necessarily having to manage the container that would be executing the code that you're writing. But I know that with Lambda, there's different options you can use for things like memory, how much memory to use for a Lambda. And with that in mind, that can actually have a significant effect on how quickly something might be executed, and could therefore sometimes make sense to use more memory to spend less because the code will actually take less time to execute. Is that something that we're looking to make obvious or easy to manage, or is it just a case of working with the configuration file directly in bref?
Right. In the previous version of bref, it was really important. Actually, that's a very good point, because it was really important to use at least 1 GB of memory, which is more than 10 times the normal amount, because you had a much more powerful CPU, and then you didn't have so much of an overhead with the JavaScript proxy. And with the new version, I want to do some benchmarks. I haven't had time to benchmark the less powerful versions of Lambda. I was always running with the 1 GB version. So that's something I have no answer today, but that's something I definitely want to explore. And right now it's that, I mean, it's really cheap. So I usually use the 1 GB version, and that's it. But it depends on the use case, obviously.
Fantastic. Thank you for that. Well, you know, from that point of view, once more, just really appreciate you taking the time to come and talk with us today. I think your energy is very infectious, and yeah, it's a very exciting project. So thanks for sharing. Absolutely appreciate it. Everybody, if you want to put your hands together, cheers. Appreciate it. Thank you.
Thank you.
One last question before you go. Do you enjoy pizza? Do you like?
Oh
yes,
I do. I do.
Well, next time I'm in France, I owe you one. I think everybody here, they can smell the pizza that's here. I'm just sorry we can't send one to you. But maybe
thanks a lot.
Maybe we can write something with bref to send you one. Cheers, mate. All the best. Have a good one.
Thank you.
Folks, alrighty, folks, let's break. Let's have a great pizza. And if you want to continue the conversation with Matthieu, his Twitter handle was there. You can share it in the community group as well. Nice one. Okay, let's grab some food. Cheers.